Hello, this is Dr. Brown, and this video we're still in the data analysis unit, and we're going to be looking at tables and graphs. This will be on page 247 to 274 in your textbook. Now, we're not going to look at every one of these graphs and tables here, but I just took sort of a random sampling on the internet of, if you look up graphs and tables, you see all kinds of ways of displaying the data that you might collect in a study. And I know you've seen this on the internet, you've seen this in TV shows, you've probably seen it in ads, somebody saying, hey, this is the best product in the world, here's the data to show it. So what we're going to start doing now is analyzing data and trying to figure out a good way to display. You have quite a lot of flexibility yourself in deciding how you want to show your data to try to get it across to others you're trying to share it with. These are just some more examples of data. This would be a pie chart. This would be a line chart. This is a bar graph vertical. This would be a bar graph horizontal. We'll be talking about this kind of graph later. You can even show maybe a map of the world and color it in different ways, where a different color might be a different condition. There are several ways that you can organize data, and this is not a complete list of ways to do it, but we have frequency and relative frequency tables, we have bar graphs and Pareto charts, pie charts, which I know you've seen before, histograms, and then a line chart. Now, what we're going to start off with is data collected from 28 drivers, and it's the number of gasolines they purchased when they stopped by a station to get some gas in their vehicle. And this data is just like randomly connected in no particular order. Now, one of the things, if you're trying to analyze data, say you're on a job and you've got data on various things, you want to try to organize it. So before we start trying to plot this or put it in a table or anything, we're going to sort it, and I will show you how you can sort it. This is data that I just put in a spreadsheet. You could simply put this data down on a sheet of paper, and notice it's in no order. But then I sorted all the data out from lowest to highest. And this is something you can do in some calculators. You can do it in Microsoft Excel. I'm not saying you need to go start using Microsoft Excel. I just use this to sort it out quickly. You could have done this by hand. So here we have the same data, and there turns out to be 28 data points in the data collection. Now, as you start to sort the data out, you can decide how to maybe display it. And in this particular example, we chose to say all the drivers who got 1 to 4 gallons. And this, so I've highlighted in this color all the ones that got 1 to 4 gallons. And it turns out, if you count them, there are 9 in the box. For the drivers who got 5 to 8 gallons, you count them, and there are 8 in the box. For the ones 9 to 12, you count them, and there are 8 in the box. And then the ones who got 13 to 16, there are 2 in the box. And then finally, there was one driver who got 18 gallons. I'm going to show you this chart a little bit later as we look at some other charts. But if we look at this data, we can create what we call a frequency table or a relative frequency table. A frequency table is one table with 2 columns. One column lists the categories, and another the frequencies with which the items in the categories occur. And a relative frequency table is a frequency table with a column of fractions or percent describing the relative frequency of each category. So let's look. If we want to create a frequency table, the categories are going to be drivers who got 1 to 4 gallons, 5 to 8 gallons, 9 to 12, 13 to 16, and 17 to 20. And these are the numbers. So using these numbers, you can see that we can create this relative frequency table. Here is the category 1 to 4 gallons, 9 drivers, 5 to 8 drivers, and so on. 17 to 20, 1 driver. The relative frequency, since there are 28 data points, that would be 9 out of 28. For the ones with 8, it would be 8 out of 28, which happens to be 2/7. And the same for category 9 through 12. And then for 13 to 16, it would be 2 out of 28, or 1/14. And then finally, for the 17 to 20, you got 1 out of 28. And then we talk about cumulative frequency, and you start from the left, and from 1 to 4, we have 9. Then if we add on the ones 5 to 8 and add the 2 together, we get 9 plus 8 is 17. And then adding on another 8 to the 17, we get 25. Another 2 to the 25, we get 27. And one more to the 27, we get 28. And we end up, the cumulative number for the highest level in the category is going to be the total that you have. Now we talk about bar charts and Pareto charts. A bar graph is a graph that displays a bar for each category, with the length of the bar indicating the frequency of that category. And Pareto chart is simply a bar chart ordered from the highest to the lowest frequency. And we'll show why that is important in a couple of examples. So if you take and look at a bar chart, recall we had 9 from 1 to 4, we had 8 from 5 to 8, and 8 from 9 to 12, and so forth. And this is a bar chart showing gallons of gas and the number of drivers who got 1 to 4 and the different categories. And this particular chart can be drawn automatically with Excel, or you could just do it yourself. with a sheet of paper. Now, pie charts. A pie chart is a circle with wedges cut out of varying sizes marked out like slices of pie or pizza. And the relative sizes of the wedges correspond to the relative frequencies of the category. Now, going back to the data to see how to make a pie chart, here are the number in each box. And here is the percentage of the data in each box. And then it all adds up to 100%. Notice there is, in a circle, there's 360 degrees. And if you look at the pie chart, remember 1 to 4, we had 32% in that box. And that arc will be 0.32 times 360 degrees, or 115 degrees. You could go get a protractor or either use Excel to draw this for you. I think this box rounded off would be 105 degrees, which would be 0.29 times 360. This box would be 104. This box would be 25 degrees. And this box would be 11 degrees. Another kind of graph is a histogram. It looks very much like a bar chart. It displays a rectangle for each numerical class interval, with the height of each rectangle indicating the frequency of values in the interval. It's similar to a bar chart, but the horizontal axis is the number line. All class intervals must be of equal width. So in this particular case, we're going to create some intervals. And just to show you the intervals that have been picked. In fact, there's no hard and fast rule for deciding the intervals. It really depends on looking at the data and decide which is a good way to display it. But the interval that's picked for this set of data is to go from 2 to 6, inclusive of 6. That square bracket means you include 6. So if you go and count the ones that from 2 to 6 inclusive, you get 2, 4, 9, 11, you get 12 data points. And so the height of that bar chart would be 12. You then go from 6, not including 6, to 10 and count up your data. That would be this data. There are like 3 7s, 2 8s, 4 9s, and add those up, and you get 10, and so forth. For the next one, going from 10 to 14, not including 10, you add those up, and you get 4. And so you have a rectangle that has a height of 4. And then finally, in the last one, 15, actually 14 to 18, not including 14, you get 2. So that is a histogram. And I know you've seen histograms like this on the news or on the internet. Now, the last kind of chart we're going to look at is a line chart that shows each category as a point connected with a line. In fact, if we look at the data again, we ask ourselves, how many 2s do we have? We have 2. How many 3s? We got 2. How many 4s? We got 5. How many 5s? We got 2. And so forth and so on. How many 9s? We have 4. And let's make a line chart of that. And it's really an up and down chart that sometimes tells you a lot, and sometimes it may not be the best way to look at something. But in this case, it turns out that the number of drivers who got 2 gallons happens to be 2. The number who got 4 gallons happens to be 5. The number that got 18 gallons was 1, and so forth and so on. So this is a line chart. And then finally, the last example I want to show you is how you would use a Pareto chart to maybe help make decisions in a restaurant business. Well, there's a restaurant business that has taken data on the cause of customer dissatisfaction. And they looked at so many customers and counted how many were dissatisfied because of the overall taste, because of food preparation or presentation, quality of service, cleanliness, etc. Now, I took this data and then sorted it out from the highest to the lowest. And that's what you do in a Pareto chart. In other words, 25 of the customers, more than any others, thought that food presentation was one item that could cause them the most dissatisfaction. And then quality of service was next, and so forth and so on. So we can take these categories and these counts and create a Pareto chart. And if you were looking at this and sitting down with folks that are trying to figure out what to do about some of these complaints, you would, hey, we really got to work on food presentation, quality of service, and of course, we want to work on all of them, but we might tackle those first. And you sure better look at the cleanliness too, because of food inspectors coming in. Anyway, that is just a first glance at how you would present data that you have in various forms.